Welcome to One Time Success, aka Diligent Tutors. Today's class is the continuation of our last physics class. We are still dealing on frictional force. We have studied the frictional force on a body placed in an horizontal surface. We have also looked at systems of bodies on an horizontal plane. We have looked at bodies placed in an inclined plane without the application of any force. Today we'll be looking at bodies that are placed on an horizontal surface with the application of a force. Let's say that we have a body. This body of mass m placed in an inclined plane with an angle theta. The force parallel to the plane tending to move the body down is W sine theta. Then the force that is applied on the body is F. We know that our normal reaction is W cos theta. So we will look at the conditions for calculation in such situation. Let's look at conditions for calculation. The first condition. Now let's assume that the body tends to move down despite the force applied upward. So if the body is about to move, slide, or at the verge of sliding down the plane, because the body is about to slide down the plane, the frictional force will be up the plane. So we can see that in this case, since the body has not actually moved but showing a tendency to move down, the force moving the body down, which is what? W sine theta, will be equal to the force moving the body up, which is the force that is applied plus the frictional force. So we can see that the force applied plus the frictional force will be equal to the force tends to move it down, which is what? Mg sine theta. Now, if we make the force applied the subject of the formula, we will have Mg sine theta minus frictional force. But frictional force is what? Mu Mg cos theta. So we have Mg sine theta minus mu Mg cos theta. So we can bring Mg out. So we can have Mg into sine theta minus mu cos theta. So that is the condition for calculation if the body tends to move down the inclined plane. That is showing a tendency to move down. Now let's look at an example on that. We said that the coefficient of static friction between a 40 kg crate, mass of the crate is what? Mass of the crate is 40 kg. Coefficient of friction is 0.25. Angle of inclination is 45 degrees. So now in this case, the body tends to what? To move down the inclined plane. Let's go through the question again. The coefficient of static friction between a 40 kg crate and a concrete surface is 0.25. Find the magnitude of the minimum force needed to keep the crate stationary on the concrete base inclined at 45 degrees to the horizontal. Now, the function of the force F is to keep the body stationary. That is preventing the body from sliding down the plane. So The force moving the plane upward will be equal to the force moving the plane downward since the plane is stationary. So we can say that F plus frictional force is W sine theta. Now we are looking for F. So F is W sine theta minus frictional force. That will give me mg for W sine theta minus mu mg cos theta. Let's write that cos theta again, cos theta. So now let's apply our parameters. Mass is what? 40. We're using 10. Your question might be 9.8. Sine what? 45 minus mu 0.25 times mass 40 times g 10 then times cos 45. So let's go. 40 times 10 sine 45 will give us 282.8427 minus, let's go, 0.25 times 40 times 10 cos 45 will give us 70.7107. Let's do the subtraction. 282.8427 minus 70.71, that will give us 282.8427 minus 70.71. That will give us 212.132, and that is approximately 212 Newton. So that is the minimum force that will keep the body from sliding down the inclined plane. So we have looked at that condition. Now let's look at the second condition. If the body is about to move up the inclined plane, the frictional force will be directed down the plane. So if the force applied, the force F, is big enough to tends to move the body up the inclined plane, then frictional force will always oppose motion. Since the body is showing a tendency to move up, the frictional force will move down. Now, so we have again the force moving the body up, which is F, will be balanced by the sum of the frictional force and the force that tends to move the body down the plane, which is W sine theta, giving us what? Mg sine theta. So the force that tends to move the body up the plane will be mu mg cos theta for frictional force plus mg sine theta for the force that is parallel to the plane when the body is showing a tendency to move up the plane. Now let's take example on that. Find the force parallel to the slope required to just move a body of mass 2 kg up the slope, inclined at 30 degrees to the horizontal, if the coefficient of static friction is 0.5. Now let's collect our parameter. Number one, we have mass. So we have the mass, which is what? 2 kg. Then angle of inclination, theta, is equals to 30 degrees. Then coefficient of friction, which is 0.5. Now, the body is showing a tendency to move up. The force moving it up is what? Is F, equals to the force opposing that motion, which is W sine theta minus, plus frictional force. That will give me mg sine theta plus mu mg cos theta. So let's put our parameter. That will be 2 times 10 sine 30 plus 0.5 times 2 times 10 cos 30. So we are going to have 2 times 10, that will be 2 times 10 times 0.5 plus 0.5 times 2 times 10 cos 30 is 0.8660. So that will give us 2 times 10 times 0.5. That will give me 10 plus 0.5 times 2 times 10 times 0.8660. That will give me 8.66. So if we add the two together, we get 18.66. So the force that tends to move the body up the plane is 18.66. Let's look further for conditions for calculation. Now in this case, if the body moves down the inclined plane with an acceleration, the frictional force will be directed up the plane. That is, if the body actually moves down with a uniform acceleration. Now, if the body is moving down, we can see that the force moving it down is W sine theta. The force opposing the motion is what? F, and the frictional force. So we can say the force moving it down minus the force opposing the motion is equal to the resultant force with which it moves. So if we open the bracket, we have minus F minus M mu mg cos theta. Then so we have mg sin theta minus F minus mu mg cos theta equals ma, making F the subject of the formula. Will have this relationship when the body moves down the inclined plane with what? With a uniform acceleration. So let's look at an example there. A force of 20 Newton. A force of 20 Newton. Let's look at that. A force of what? 20 Newton. The force applied. A force of 20 Newton was applied on the body of mass. The mass of the body is 5 kg. To move it up the plane, incline at 45. Angle of inclination is 45. However, this force was insufficient to move the body up the plane. As a result, the body moves down the plane. What is the acceleration of the body if the coefficient? Now we have our mu, coefficient of friction is 0.25. So let's go. The force moving the body down, W sine theta, is equal to the force opposing that motion. The force moving the body down, W sine theta, minus the force opposing the motion, which is F plus frictional force, is equals to the resultant force with which the body moves down. And from here, in our previous slide, we can see that F will just be, let's go through that, let's not assume. If we open the bracket, W sine theta minus F minus frictional force is equals to MA. So we can say that W sine theta minus frictional force minus MA equals to F. So F will give me mg sine theta minus frictional force, which is mu mg cos theta minus ma. So let's put our parameter 5 times 10, 5 times 10 sine 45 minus 0.25 times, sorry, let's go through that again. Now let's look at that again. A force of 20 Newton was applied on a body of mass 5 kg. So the force on the body is 20 Newton. The mass is 5 kg. The angle of inclination is 45 and the coefficient of friction is 0.25. From our previous slide, you can see from our previous slide that in this situation we have the force equals to mg sine theta minus mu mg cos theta minus ma. So let's go. So we are going to have the force F is equals to mg sine theta minus mu mg cos theta minus ma. So this force is what? 20 Newton. Mass is 5 times 10 sine 45 minus 0.25 times 5 times 10 cos 45 minus 5a. So we can just say that minus 5a equals to 5 times 10 times sine 45. What would that give us? 5 times 10 sine 45. That will give us 35.3553 minus 0.25 times 5 times 10 cos 45. That will give us 8.8388. Now minus 20 that will carry over. So we have 5a equals to, let's do that mathematics, 35.3553 minus 8.8388 minus 20. That will give us 6. That was 6.5165. So A will be 6.5165 over 5, which gives us 1.3033 meter per second squared. So the acceleration with which the body moves is 1.3033 meter per second. So we can even approximate that to 1.3 meter per second. squared. All right, let's move on. Let's look at the last condition for calculation. If the body moves up the inclined plane with an acceleration, the frictional force will be directed down the plane. This time, the force is able to move the body up the plane. So we have the force moving the body, which is F, minus the force opposing the motion is equals to the resultant force, from which we get the force moving the body to be MA plus frictional force plus mg sine theta. And that will be F is equals to MA plus what's frictional force? Mu mg cos theta plus mg sine theta. So that is the force that moves the body down the inclined plane. So let's take an example. If the force parallel to the plane required to move a body of mass, now the mass of the body is what? Mass is 2 kg. Of mass 2 kg up the plane, inclined at an angle 30 degree to the horizontal with an acceleration. Now we were given the acceleration, which is 2 meter per second square. If the frictional force between the body and the plane is 10 Newton. Now this time we were given the frictional force. So let's go. The force moving the body, which is what? F, minus the force opposing the motion, W sine theta plus frictional force will be equals to MA. So F is just MA plus W sine theta plus frictional force. So what is mass? 2 times acceleration, which is also 2, plus W, which is what? Mg, that is mass times acceleration due to gravity, sine 30, plus the frictional force, which is 10. So if we do that, that will give me 4 plus 2 times 10 sine 30, that will give me 10 plus 10. So if we sum them up, that will give us 4 plus 10, 14, plus another 10, which is 24 Newton. So the force that is capable of moving this body with an acceleration of 2 meters per second square is what? 24 Newton. So we can see that when a body is placed on an inclined plane and a force is applied to it, we have 4 conditions. Let's go through those conditions as a summary. Now, the first condition is that if the body is about to slide at the verge of sliding down the plane, if the body is about to slide down the plane, that's the first condition. Now, the second condition is if the body is about to move up the inclined plane, not actually moving, but about to move up the inclined plane. The third condition is if the body actually moves down the plane with an acceleration, with a uniform acceleration. And the last condition is if the body moves up the plane with a uniform acceleration. So when a body is placed in an inclined plane and a given force is applied to the body, we have 4 conditions to consider in our calculation. Thank you.